Today we're going to learn how to graph exponential and logarithmic functions. So first of all, let's talk about the difference between the two. Exponential functions always come in this format. Notice it's going to be a number to the x power, so the x is the exponent. Logarithmic functions, or just logs for short, look like this. They will literally have the word log in them and then a little base number at the bottom. It's kind of like the opposite position of an exponent. So every exponential function, b to the x, looks exactly the same. You graph 2 points, 0, 1, always 0, 1, and then the point 1b. So this b is that b right there. So if there's a 5 there, it's 1, 5. If there's a 2 there, it's 1, 2. And then there's always going to be an asymptote line. So let's go ahead and draw this in. That asymptote line is going to be at 0. Horizontal asymptote at y equals 0. Now the log graph is just pretty much just the opposite. So notice you have your first point at 1, 0 as opposed to 0, 1. And then you have b1 compared to 1b. So again, whatever this base number is, if that's a 3, that'd be 3, 1. If that's a 7, that would be 7, 1. And we have a vertical asymptote at y equals 0. All right, so let's graph a couple of these. Always making sure that you're able to tell the difference between whether it's exponential or log. So 2 to the x means we always have a point. It's exponential, always have a point at 0, 1. And then the next point is going to be at, you can see right here, 1, comma, b, and our base is 2. So 1, 2. Plot the point 1, 2. And then it just looks really kind of a straight line right there, and then it curves upward. And just so we get in the habit of it, I'm going to graph my asymptote line across at y equals 0. The next one is a log graph, so we always graph the point 1, 0 for logs, and whatever your base is, comma 1. So 1, 0, be over here, 3, 1, like that. And again, you have it curving up and around. And then your vertical asymptote line there at 0. All right, example number 3, it's back to an exponential graph. So we'll start off by putting that there. And you have 0, 1. Again, I'm getting these from right here. 0, 1, and 1, 4. All right. 3 to the x, and you can do these without writing out the points if you want. Point right there, and then 1, 3. Asymptote line across. Log, asymptote line up and down. And always 1 point over. And then I'm going to plot the point 2, 1. So always having that same shape, it's just a matter of where that second point goes. And log base 5 of x, we put a 1 right here, and then we come all the way out to 5, 1, and make it curve up like that. Finish it off with that asymptote line. And there we go. So that's how you draw the base of the graph. On the back side, we're going to learn how to shift these. So these shifts, these transformations as they're called, are very similar to what we've done in the past. If you see a number on the inside, so right here, this -4, that's actually going to move it to the right 4. So it always looks the opposite. Your right, left always looks the opposite. All right. Now that little 3 right there, that's not going to do anything for the transformation. That's not going to move the graph. That's the dot that's going to help us plot that first couple points. Example number 8, that minus 6, x minus 6 would be to the right 6. And it's almost like there's a parenthesis right there, except because it's all part of the exponent, they don't write the parentheses. So just know that that's the equivalent of having parentheses around there. And then plus 2 means we would go up 2. Minus 5 here at the end, it's not inside a parenthesis. So this means that's going to move down 5. Example number 10, that plus 2 inside the parentheses, left 2, plus 1, up 1. The minus 7, again, it's not part of the exponent, so it would not be counted as part of the parentheses, so down 7. And this is part of the exponent, so that's going to be left 1. So for the right left, it's either going to be in the parentheses or part of the exponent. And then up and down is going to be the number at the end. All right, so example number 13, we're actually going to graph these. You can see that the original graph has been done for us. We have a point here at 0, 1, and then 1, 2. And this 3 right here is going to help us move the graph. I need to move everything up 3. So what's not drawn was your asymptote line, but you can see it's always going to be at that 0. So if you wanted to draw it lightly at the beginning, you could kind of draw it in there. But if you graph these on a computer, on a graphing calculator, the asymptote line isn't shown. All right, now let's move everything up 3 places. So I'm going to take this dot first and move it up 1, 2, 3. This dot next and move it up 1, 2, 3. And then finally the asymptote line, I'm going to move up 1, 2, 3. And I'm going to draw that new asymptote line at 3. And then just come in and make that same exponential graph shape. On the next one, minus 2 inside of parentheses is going to move it right 2. And then minus 4 at the end, down 4. So I'm going to move each dot right 2, down 4. I'll start with this one, right 2, down 4. Moves to there, again from here to there. Right 2, now this one, down 4. You can see you're going to have that exact same shape. Dots should be the same distance away from each other. Then I like to move my asymptote line, which was originally here. It always starts off at a 0, either x equals 0 or y equals 0. And then we're going to move that to the right 2. There's no purpose in moving it down 4 because it's a line, and a line kind of keeps going. This line keeps going up and down in both directions. So if you move a line down 4 and it's already up, down, it does not change the line. There we go. All right. On the very last 2 examples, we're going to have to draw the original graph, and then we're going to have to shift it. So I'm going to draw my original graph in blue. And again, the original graph would just be 4 to the x. Right? I want to ignore the 2 and the 5 at first and just draw 4 to the x. So for 4 to the x, I'm going to have a dot at 0, 1 and a dot at 1, 4. And I will have my asymptote line across here at y equals 0. Once you have the original drawn, then you can transform it. You can shift it. So plus 2 is going to move left 2, plus 5, up 5. So let's take our blue dots and move them left 2 and up 5. Left 2, up 5. Again, they should end up being the same distance apart. And then I'll move my asymptote line. Again, this asymptote line is going in the left-right direction, so moving it left 2 is not going to matter. I'll just move it up 5. Ends up being right there. And then that helps me draw my exponential graph the right shape. All right, and example number 16, again, we'll start off by drawing that in blue. We're just going to start off by graphing log base 2 of x. So we'll have our first dot at 1, 0, our next dot at 2, 1. Draw the asymptote line in. Remember, your asymptote line on this one is vertical. You can draw that log graph in. Then I'll switch colors for us. X plus 6, that plus 6 is inside the parenthesis. So it's going to move to the left 6 places. Start with my dots. One would go there. One would go there. And then I'll take my asymptote line and move it left 6. And then there's my final answer. Now remember, the blue graph is not part of it. So in reality, what you would do is just kind of go in and erase this stuff. It's not always necessary. Sometimes it's easier to draw it really lightly and then darken in the final answer. Or if you want to go back and erase, that's fine. Or if you want to leave it all there, that's okay too.